So on today's agenda is the next homework assignment, which is chapter 8.3, last one. Using a hash map and vectors, create a text interface to allow a user to add employee names to a department in a company. For example, add Sally to engineering or add Amir to sales. Then let the user retrieve a list of all people in a department or all people in the company by department sorted alphabetically. I'm gonna be real with you guys. I went through this, I did it, I have a working implementation, but it took me a very long time to do, and I'm kind of fuzzy on some things. But let's start. So let me take this statement here so we don't have to reference it again. Control copy. And let's go to our editor. Here we go. And just have a blank one. I have this line here for something that we're gonna have to look at later, but that's how I went about finding it. And at the top here, let's just put the statement. All right, so what are they asking here? We see they want us to create a text interface to allow a user to add employees. So a text interface, what does that mean? That, at least to me, means that we have a sort of a running program that takes input over and over and over again until the user decides to exit. In order to do that, we have to understand and make a program to take input, standard in. And that's what this link is here for. I already have it open. Let me just open the browser again. So I'll try to look into ways of using standard in. And after a while, it seems as though this Stack Overflow post is what I found to be the most useful. This one right here. They listed out for different versions of Rust, but we're using this one. And what they say to do is use this, and then write this. So let's move this to the side and see if that works. Actually, what was it again? We have our let standard in equal IO, which we're gonna have to import, standard in, and then we call it, right? And then for line in standard in dot lock dot lines. In this loop, we print out line dot unwrap. So right now this should work because we don't have anything imported. What they say to import here is the standard libraries IO. And I'm going to not import the second one just because I think there's another way of going about doing it. So if we hit cargo run on this should fail. And it does. And we scroll up here, and this is what they tell us to do. They tell us to use the IO buffer to import this. Control copy. Put that here. Fix the line there. And let's do this again. We have our running program. Hi. Hello. Yes. So this is what we wanted to do. We want to be able to constantly take in input for the program. Why did this work? So let's start doing some research, or I did some research. IO.standard in, right? Anytime you want to get into standard in, let me make this big. Anytime you want to take an input from your standard input, you should look for a standard input package. In this thing, go back to the editor, that's this one. In the editor, what we did was we took io.standardin, and we called it, which returned a standard in struct, let's say. And we're in that package now. So what they say here is that each handle is a shared reference to a global buffer of input data to this process. A handle can be locked to gain full access to the buff read methods. And then seemingly you take in the input and it goes into this buffer, and this is the global buffer for all of your input, and thus you're accessing it. So back to our editor. What we noticed earlier was that when we didn't have this line, comment it out, Control C out of that, and we try to run this, we got this error that's saying to add it. This is seemingly associated with traits, as in you have to have it imported so you can use these traits or use the methods on the buffer, because this returns or has access to a global buffer. That is my understanding of it. I could be wrong, but it happened again. I could be wrong, but that's what it seems is happening. So to be clear, we get a standard input, let's say object, right? We call lock on it to make sure that nobody else has access to the buffer, the global buffer for standard input. And then we call lines on it. And this is currently reading from the standard input, which we have down here. Right? And it's continuously reading because we're just in a for loop. We have no way of exiting right now. And we're taking each line and we're unwrapping it. But the reason why we can get access to this buffer is because we have this imported. So that is vital. And then currently to exit, you can either do Control C or Control D. Either of those will exit out of a standard input loop. That's just basic Unix. All right, so now that we have a for loop and we have a standard input coming in and we can write out, let's take a greater look at what this line is. This line says it's a result string error. To me, that sounds like an enum. This also sounds like something that goes over, that the next chapter will go over, because they cover error handling. However, we're not there yet, so we can just guess at it until we see what we actually have to do. But like other enums, we could probably just put it into a match. And I think it's okay. I think the options are okay and error. And then error. And then I'm having trouble with my mouse. And then okay, just like with other enums, we have whatever it is in the enum, and this is string. And here we can just say print string. Print line, line, right? And we can make this code block pretty, give it some spacing. And then for the error, I don't know what we want to do for errors. Print line, there was an error. Leave it like that for now. And try to run this. And we got an error. Expected one field found 0. I'm gonna put an underscore there. Will that do it? Buffer IO print. Oh, this imported something that we don't need. And one more time. And we're back to what we had before. A loop that just takes stuff. Control D. Alright, so now that we have a loop, we need to be able to parse the words that are coming in. And the example they have here is add Sally to engineering. Add Amir to sales. In order to do that, we have to have 1, we have to know what add means. We have to take in the second character, or word, I should say, Sally. The 2 seems like it doesn't really matter. English it does, but in terms of our program it doesn't. And then engineering is the department. So at least for this sentence structure, we have 4 parts. We have our add, which says we're going to add something to our task map, which we haven't defined yet. And we have a name, which is the name of the person that we're adding to that department. We can skip the 2, which is going to be still a valid part. And then we have sales, which is the name of the department. In this case, it's engineering. So we learned how to, or we went over breaking a string into words, which was splitting them. If I remember correctly, I think it's like we're going to also need the index, because you need to know that this is the first word, second word, third word, fourth word. So let's go with index, word, get them back. For index word in line dot trim, because we want it to be slim. And is it char? No, it's split by white space. Oh, dot enumerate. And then now we should be able to see the word. So let's just print this out to make sure we have what we want. Print. Go index and word. Index, word. And then we have the line down here, but actually we can move the line up so we can see the entire line. Exit out of that, put that here. So we print out the line first and then we break it down into words. See what that gives us? Hello, I know you. Ta-da! Okay. We have our line here that gets printed, and then we go through the line, split it by white space, and now we are printing out each word. So in the case that this word is add, we need to do something. And arguably, for the second part, it says, then later the user can retrieve a list of all people in a department or all people in the company by department. This sounds like the user should be able to say something like show department name, and it gives you all the people in that department name, or sorry, in that department in alphabetical order. And then the second part is all people in that company by department, sorted alphabetically. This sounds like you can get all the people in the company by department, and they are sorted alphabetically within the company. At least the names are. I'm not sure if the departments are sorted. I'm not sure if I can sort the departments. Technically speaking, I don't think I can. But we can get to that. But the important thing to note here is that we have some keywords. We have add, which goes down one logic tree where we want to then add a person, Amir. I just changed the name. Amir. Add a person to a department. So that's one tree that starts with add. And then we have another tree that starts with, in our case, I'm gonna say show. Show department or show company. And that'll give us our 3 different options. So our next part is that we want to take in these keywords and break it down. A keyword I forgot to mention while we were looking up here is exit. We want the person to be able to exit the program. So these words, right? So I'm gonna create a temporary variable called word, just because we may need to do some mutations on it. One, when we're comparing, looking for our keywords, I don't care if it's capitalized or lowercase. They should all just match. If you say add, regardless if it's capitalized or lowercase, it should work. So we need to compare words seemingly in the lowercase. Make everything lowercase and just compare them. So to do that, word dot trim dot to lowercase dot to string, right? And then we can say if underscore word dot equal, and then give it another string to be equal to, add dot, I think it's to string, to make the comparison, print need to add to a department, right? Ooh. Else if, which is underscore word dot equal, we said show, make that a pointer to string, print need to show something, and we wanted an exit, right? Else if word dot equal pointer exit dot to string, print line exit, and let's see if this works. See how that. All right, we have our loop. Let's do add something. Something I could spell. And it says need to add to a department. So that we went through the loop. It parsed the add out in the first word and then went into this clause, right? Technically speaking, if we go into this clause, we should probably, like right here, pass the line into a different command, pass the line into another function to handle adding to a department. And then make sure the show works. Show me something. Show me something. Function has an N in it. Here we should do something similar. Pass into a show function. And then exit. Exit, please. We got exit. And we should probably just exit. I don't think we can break out of this loop because this is a loop within a loop. So, in order to deal with exit, let's create another variable. Let's call it, put it right here. Let exit equal false. No, exit has to be mutable because it has to change. Exit equal false, right? And then down here, where's the loop? For loop. That line down here. If exit break. And then down here, if we see exit, just set it. Exit equals true. And let's see if that works. So we did add something. Add works. Show show works, exit. As you can see, it exit out of the program. One thing else I want to show you guys is some issues that we have with our current loop and how it's working. So if we did show, add, show, we now get show something, add something, show something. We have not limited this search to the first word. We can think of it two ways. We have not limited search to the first word, so that's one thing that's flagging. If somebody's name was add, God forbid, at least for this program, that would ruin things. So what we can do is that after we see our first keyword, we could exit. Not exit out of the entire loop, but we can exit out of the for loop for the words. So we can do a break here. All right. And the same thing here. Put a break. And technically speaking, for exit as well, break. Because after you type exit, do you really need anything else? Oh, exit works. You can just type exit. So run this again. Now if we do the same thing, show, add, show, exit. All we get is show because that is the first word that was seen, which is what we want, essentially. We only want to look at the first word. Given that we only want to look at the first word, I think we may have another issue. What about if it is blah, 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 and then show, and then add, and then exit? We still need to show something. So this didn't brace it enough. We should also limit this stuff, all of this stuff, to if the index is 0. And then put all of this stuff in there. I think it indented for me. So now let's exit. Do this again. We did this case, show, and then add, right? It goes through all of the words and it ignored the show that was the second word, because our command should be coming first, not second. So now we have a kind of a skeleton of what we need to do. We have ability to exit. We have our for loop. First and foremost, we have our for loop to create the text interface, which is what we've been writing right here. And then we have the outline of what needs to happen. If it is add, we have to create a function and then do the add stuff. If it is show, we have to create a function, do the show stuff. And if it is exit, we just exit out the program. Given how long this program took me to write, I might put this in 2 parts, and this might be the end of the first part. Just a heads up.